Brain NeuroGov Plus Architecting Brain NeuroGov Plus. How DFDs, process flow, data flow, system flow, KPI plus TSI, and OSI, calculation, support enterprise architecture. 1. Introduction. Architecting Brain NeuroGov Plus requires more than defining individual AI components. It requires a structured way to understand how information enters the enterprise, how processes transform that information, how systems interact, and how performance and operational success are measured. The framework presented here uses data flow diagrams, DFDs, process flow, data flow, system flow, KPI, TSI, and OSI as complementary architectural and measurement tools. Together, they provide a blueprint for designing, analyzing, governing, and continuously improving Brain NeuroGov Plus. 2. Data flow diagram, DFD. A data flow diagram, DFD, shows how data moves through a system, including the processes that transform data, data stores, and external entities. In Brain NeuroGov Plus, a DFD helps establish the boundaries of an enterprise intelligence system and identify where information originates, where it is processed, and where it is stored. It therefore supports system scope definition, identification of data sources and destinations, analysis of data transformations, and architectural requirements. 3. Process flow. Process flow describes the sequence of activities required to achieve a specific outcome or complete a business process. Within Brain NeuroGov Plus, process flow can represent the controlled sequence from input understanding through analysis, governance, decision processing, and response or action. It is particularly useful for defining workflows and procedures, standardizing processes, improving consistency, and supporting automation and control. 4. Data flow. Data flow focuses specifically on the movement of data between sources, processes, destinations, and data stores. While a DFD provides a broader system representation, data flow allows Brain NeuroGov Plus architects to examine individual data movements in greater detail. This supports data dependency analysis, data integrity considerations, detailed system design, and the alignment of information movement with enterprise intelligence requirements. 5. System flow. System flow provides a higher-level view of how an entire system and its major subsystems operate together. For Brain NeuroGov Plus, this is important because the architecture consists of multiple intelligence, governance, knowledge, memory, analytical, and enterprise components. System flow helps architects view the system as a whole, define subsystem interactions, support architectural design, and align the technical structure with strategic enterprise objectives. 6. KPI Key Performance Indicator. KPI, Key Performance Indicator, provides a quantitative measurement of performance against a defined target. The framework shown in the architecture uses the basic calculation. KPI equals actual performance / target performance times 100. KPI therefore provides an outcome-oriented measurement layer for Brain NeuroGov Plus. It can be applied to measurable enterprise objectives and used to determine whether a target has been achieved or exceeded. A KPI of 100% or more represents target achievement or better performance, while a KPI below 100% indicates that the target has not been achieved. 7. TSI Technical Success Index. TSI, Technical Success Index, measures the technical health, reliability, and quality of the system. The framework defines TSI using the relationship TSI equals sigma technical success factors score / maximum possible score times 100. Technical factors may include reliability, performance, security, scalability, availability, maintainability, and data quality. For Brain NeuroGov Plus, TSI provides a technical health perspective that complements business performance measurements. It helps determine whether the underlying architecture is technically capable of delivering reliable enterprise intelligence. 8. OSI Operational Success Index. OSI, Operational Success Index, measures how effectively the system delivers business value and operational effectiveness. The framework identifies factors such as process efficiency, user satisfaction, adoption, compliance, cost effectiveness, and value realization. The calculation is OSI equals sigma operational success factors score / maximum possible score times 100. The OSI therefore extends architectural evaluation beyond technical operation and asks whether Brain NeuroGov Plus is delivering meaningful operational outcomes. 9. Integrated KPI plus TSI plus OSI architecture. The three measurement dimensions can be integrated into an overall success view. OSI equals W times KPI, plus W2 times TSI, plus W3 times OSI. Where W, W2, and W3 represent the selected weightings and their total equals 1.0. This creates a multidimensional evaluation framework combining performance achievement, technical success, and operational success. In the Brain NeuroGov Plus architecture, these measures can support continuous monitoring, governance review, management intelligence, and data-driven improvement. Summary. The architecture of Brain NeuroGov Plus can be understood through complementary layers. DFD rightward arrow process flow rightward arrow data flow rightward arrow system flow rightward arrow KPI plus TSI plus OSI. DFD establishes how information moves through the system. Process flow establishes how activities are executed. Data flow provides detailed visibility into information movement. System flow connects the major components and subsystems into an overall architectural view. KPI, TSI, and OSI then provide quantitative mechanisms for evaluating performance, technical health, and operational success. Together, these concepts provide an architectural language for designing and evaluating Brain NeuroGov Plus as a governed enterprise intelligence system. Power summary. DFD explains where data moves. Process flow explains what happens. Data flow explains how information moves. System flow explains how the whole system works together. KPI measures performance. TSI measures technical success. OSI measures operational success. Together, they provide a structured foundation for architecting, measuring, governing, and continuously improving Brain NeuroGov Plus. About Dr. Pradeep K. Suri. Dr. Pradeep K. Suri is the founder and architect of Brain NeuroGov Plus, an advanced AI, enterprise research and innovation program focused on governed, cognitive, intelligent, and responsible enterprise artificial intelligence. Architectural approach brings together AI governance, AI memory, cognitive reasoning, decision intelligence, responsible AI, enterprise knowledge, specialized AI engines, and enterprise cockpit-based decision presentation into an integrated enterprise intelligence framework. The methodology presented in this video extends that architectural vision by establishing a practical relationship between information movement, process execution, system architecture, and measurable enterprise outcomes. Architectural principle. Architecting intelligence rightward arrow governing outcomes rightward arrow measuring success rightward arrow delivering enterprise value. Dr. Pradeep K. Suri. Founder and architect, Brain NeuroGov Plus.